Welcome to Sugosha Media News, your quick briefing on the top defense technology and global security headlines for 14th of July 26. Today's Defense and Aerospace Roundup highlights India's accelerating push towards technological self-reliance and the growing role of autonomous systems in modern warfare. We cover the launch of NIDAR 2.0 by MeitY and Drone Federation India to foster indigenous drone innovation. India's landmark decision to open ASTRA Mark II missile production to the private sector, and Indian Army's pursuit of AI-enabled 1,000-kilometer long-range loitering attack drones. We also examined Ronyard Spector surveillance UAV demonstration for the Indian Army, the strategic collaboration between AWEIL and IIT Kanpur to develop indigenous UAVs and advanced defense technologies, and Spry Technocon's partnership with global leaders Teledyne, Klein, and VideoRay to strengthen the Indian Navy's mine warfare capabilities. In addition, we explain how active electronically scanned array radars have transformed modern military operations and conclude with a look at significant global development, the first reported combat use of unmanned sea drones by the United States during strikes on Iran, highlighting the rapid evolution of autonomous warfare across land, air, and sea. The news in detail. Ministry of Electronics and Information Technology (MeitY), in collaboration with Drone Federation India, launched the second edition of the National Innovation Challenge for Drone Application and Research (NIDAR 2) under the SWAYAN initiative. NIDAR 2 raises the level of the challenge. It moves the focus from conventional airframes to autonomous systems, indigenous avionics, and core drone components. The challenge runs across two tracks. Track 1, Drone Innovation, tasks student teams to build fully autonomous swarm drones that can locate survivors and deliver medical parcels in a disastrous zone without any external communication network. It also challenges teams to develop a GPS-denied drone that can navigate confined indoor spaces for industrial inspection. Track 2, Component Innovation, challenges teams to design an indigenous flight controller and autopilot built around the Vega processor using indigenous electronic components. After technical evaluation, the top 100 teams will each receive 2 Vega processor kits for development, testing, and integration. The Vega processor is a family of indigenous microprocessors designed by the Center for Development of Advanced Computing (CDAC) under MeitY's Microprocessor Development Program, based on the open standard RISC-V architecture. India has initiated a defense manufacturing reform by opening missile production to private firms, with the DRDO-developed ASTRA Mark II said to be the first program under this framework. The move aims to expand production capacity, meeting rising domestic and export demand, and position India as a major global defense exporter. The Astra Mark II missile, designed by DRDO, will spearhead this transition. With a strike range of more than 180 to 200 kilometers, it is capable of engaging enemy aircraft well beyond visual range, significantly enhancing the Air Force's aerial combat capabilities. Indian Army has initiated the long-range Loiter Munition program under the Make-II category to develop indigenous AI-enabled one-way attack drones with a strike range of 1,000 kilometers. Unlike conventional UAVs, these systems are designed for deep precision strikes in GPS-denied environments using AI-assisted navigation, autonomous target recognition, and multiple attack profiles such as terrain following and steep dives. The program requires indigenous development of engines, EO payloads, avionics, airframes, and warheads, strengthening India's defense industrial base while creating a scalable autonomous strike ecosystem for future warfare. Ghaziabad-based Drone Yards has recently demonstrated its indigenously developed Spector surveillance UAV to the Indian Army, underscoring India's growing reliance on homegrown unmanned aerial systems for battlefield intelligence and reconnaissance. Drone Yards, headquartered in Ghaziabad, has already established itself as a key contributor to India's indigenous drone ecosystem. Earlier this year, the company supplied over 200 advanced first-person view drones to the Army and trained more than 350 soldiers in their use. These drones were designed with electronic warfare resilience, secure telemetry, and triple radio redundancy to ensure reliability in contested environments. The demonstration of the Spector UAV builds upon this foundation, showcasing a platform tailored for long-range surveillance and persistent battlefield awareness. The Spectre UAV is understood to be a fixed-wing surveillance platform optimized for endurance and stability. Its role is to provide commanders with real-time intelligence, surveillance, and reconnaissance data across diverse terrains. The Advanced Weapons and Equipment India Limited AWEIL has signed a memorandum of understanding with Indian Institute of Technology Kanpur to jointly undertake research, design, development and commercialization of next-generation indigenous defense technologies. The partnership will focus on development of unmanned aerial vehicles, advanced ballistic systems, smart ammunition technologies, autonomous weapon platforms, artificial intelligence-enabled defense solutions, advanced materials, simulation technologies, precision engineering, robotics, guidance and control systems, embedded electronics, sensor technologies, and other emerging military systems. The collaboration will leverage IIT Kanpur's research capabilities and innovation ecosystem, together with AWEIL's expertise in defense manufacturing, weapon systems, and industrial production. The MOU also envisages joint research projects, technology transfer, prototype development, product testing, industry-academia knowledge exchange, skill development programs, internships, incubation support for defense startups, and the commercialization of indigenous defense technologies. The partnership is expected to accelerate the development of advanced indigenous military products, strengthen India's industrial base, and support the government's Make in India initiative by reducing dependence on imported defense technologies. Spry Technocon, an Indian deep tech startup focused on maritime and underwater technologies, announced a strategic partnership with Teledyne Marine, Klein Marine Systems, and VideoRay, an AV company, to jointly address emerging opportunities in advanced unmanned mine countermeasure systems for the Indian Navy. The collaboration brings together world-leading capabilities in underwater sensing, imaging, and remotely operated systems with indigenous engineering, integration, and life cycle support capabilities in India. The partnership aims to offer a comprehensive and modular unmanned MCM suite, supporting the Indian Navy's future mine countermeasure vessel and autonomous mine warfare requirements. The proposed solution will integrate advanced technologies including autonomous underwater vehicles and mine detection, classification, and identification capabilities from Teledyne Marine, high-resolution side scan sonar and seabed mapping systems from Klein Marine Systems, remotely operated vehicles and expeditionary mine countermeasure capabilities from VideoRay, an AV company, mission planning, data processing and operator support systems, system integration, testing, indigenous manufacturing, and through life support capabilities by Spry Technocon in India. Now a brief analysis of the AESA radar. Before modern radar systems could track multiple threats simultaneously, rotating antennas scanned the horizon slowly, creating delays in target detection. The arrival of active electronically scanned array technology changed that equation entirely. Instead of physically turning towards a target, AESA radars could redirect beams electronically in fractions of a second, faster, quieter, and far more resistant to jamming. Today, AESA systems sit at the center of modern air combat, missile defense, naval warfare, and surveillance networks worldwide. This guide explores what AESA radar is, how it was developed, its major variants, how it works, and why it has become one of the defining technologies of next-generation military sensing. An AESA radar uses hundreds or even thousands of small transmit-receive modules TRMs to electronically steer radar beams, enabling rapid target scanning without physically moving the antenna. This architecture enables AESA systems to track multiple threats simultaneously, switch between missions quickly, and operate more effectively in environments vulnerable to electronic attack. AESA radars are now widely used on fighter aircraft, naval warships, airborne early warning systems, ground-based air defense networks, and even some space tracking applications. The foundations of AESA can be closely tied to the development of the passive electronically scanned array radar in the 1960s, but the true AESA breakthrough came with the development of compact solid-state TRMs capable of independently generating and receiving radar signals. Defense companies like Raytheon, Northrop Grumman, and Lockheed Martin, as well as European and Japanese firms such as Thales, Leonardo, Mitsubishi Electric, played major roles in advancing operational AESA systems. To understand what makes AESA a genuine leap, it helps to understand what it replaced. Older mechanically scanned radars worked exactly as they sound. A physical antenna rotated to sweep the sky, painting a picture of what was out there one arc at a time. That rotation took time. In the gap between sweeps, a fast-moving target could move, a missile could close distance, or a threat could disappear entirely. The radar was only looking at one place at a time. AESA eliminates that constraint at the hardware level. Instead of one antenna moving through space, an AESA array consists of hundreds or thousands of individual transmit-receive modules, each capable of sending and receiving radar signals independently. By adjusting the timing and phase of signals across these modules, the system can steer a beam in any direction almost instantaneously, no moving parts, no mechanical delay, no blind spots between sweeps. Electronic beam steering means an AESA radar can be tracking an incoming missile, mapping terrain below, and scanning for new contacts simultaneously, tasks that would have required separate dedicated systems on an older platform. A fighter pilot gets a single integrated picture rather than switching between modes and losing awareness in the transition. News from the war zone. US forces have used unmanned surface vessels for the first time in combat operations, striking a submarine and ship maintenance facility in Iran, according to US Central Command. In a 24-second unclassified video posted by CENTCOM, 3 unmanned surface vessels are shown individually approaching shoreline infrastructure. The same dock appears to be the target in 2 of the clips. The video then cuts to a first-person view from what appears to be the bow of one drone, showing the final approach to a dock that appears to be housing an exposed small submersible. Cutting back into an overhead view, the final seconds of the video shows clips of 3 explosions. Now a quick wrap of today's news. Today's defense and aerospace news highlighted India's accelerating push for indigenous capabilities with the launch of NIDAR 2.0, Army's pursuit of AI-enabled 1,000-kilometer long-range loitering munitions, demonstration of the Spector surveillance UAV, and a strategic collaboration between AWEIL and IIT Kanpur to develop next-generation defense technologies. The government's decision to open missile production to private industry, alongside the continued development of the ASTRA Mark II, marks a significant policy shift, while Spry Technocon's partnership strengthens India's naval mine warfare capabilities. The growing importance of advanced technology such as AESA radars and the United States' first operational use of sea drones in combat underscore how autonomy, AI, and unmanned systems are reshaping modern warfare worldwide. Thank you.